So this is the program which you need to execute in the Advanced Communication Lab. The program is PCM, Pulse Coded Modulation. So when you run this program, so it asks for an input, enter the value of n bit. It is considered as a 3 bit. Then it asks for number of samples. It is considered as 8 samples. When you run this, and this is the output which you will be getting. So let me explain you the concept over here. So this is your analog signal. So this signal has to be digitized, then it will be quantized, and it will be transmitted. So after receiving the data, whatever it is quantized, it will be dequantized, and again the original signal will be reconstructed. So this is your analog signal. So its amplitude is 8. Okay, so if you consider here, the amplitude of this is the amplitude of this is 8, and the maximum negative amplitude is -8. So in order to sample this signal, we are making use of 8 samples. So that is what was given at the input. Okay, so using 8 samples to represent this image. Okay, so look over here, 1 2 3 4 5 6 7 8. So there are totally 8 samples which is used to represent this image. Okay, so the analog signal will be converted to some digital samples. So you could look at the value of the sample over here. So its value is what? 8. So this is being what? Sampled. So it is represented in terms of discrete. So here the amplitude was 8. Here also the amplitude is what? 8. So here it was -8, and here also it is -8. Now what we need to do is we need to quantize this signal. Okay, we need to quantize this signal. You just look over here. So here it was 8. Here it is 8, and this is what? The value is what? 7. So 8 value is being quantized to value 7. Okay, similarly all the other digital values will be quantized. So when we quantize this image, okay, so we'll be using levels. Okay, so we'll be using levels that depends upon the number of samples which you have taken. Okay, that is number of bits which is used to represent the quantization. So we have taken n bit. Okay, so the number of levels will be 2 to the power of n. So since it's a 3 bit, so 2 to the power of 3, so that will be 8. So there will be 8 levels. Okay, right from 0 to 7. Okay, 0 to 7. We'll be using these quantization level. Okay, we'll be using these quantization levels to represent the signal. Okay, so now just look out this. Okay, so this is the signal. Okay, this is the signal 0, 5.69, 8, 5.69. So whatever the samples which you have taken here, so its value is represented. S is equal to 0, 5.69, 8, 5. So these are the values corresponding to these samples. Okay, next, so this is being quantized. Okay, so this is being quantized. When you quantize this, so the value is 0 is represented by -1. Okay, the value is 0, that is 0, will be represented by -1. Then the value 5.65, the value 5.65 will be represented by 5. Then the value 8, okay, this 8 will be represented by 7. Okay, this value will be represented by 7. Okay, similarly all the other values will be quantized. So if you look over here, these are the quantized levels. Okay, So 5.69 will be represented by 5, 0 by 1, minus 5 by minus 5, 8 minus 8 by minus 9, minus 5 by minus 5, minus 0 by minus 1. Okay, so these are the quantized value representation. Next, we have taken 3-bit interval. Okay, we have taken 3 bits, so the number of levels should be what? 2 to the power of 3, so that would be 8, right from 0 to 7. Okay, so whatever may be the quantized value, it has to be represented between what? 0 to 7. So if you look over here, minus 1 is being represented by 3. Wherever the amplitude is minus 1, it will be represented by 3. You look over here, minus 1, it is represented by 3. So whenever you come across 5, it is represented by 6. 7 is represented by 7. So look over here, 5. So 5 should be represented by 6. So it is represented by 6. Next, 1 is represented by 4. Minus 5 is represented by 1. Minus 9 is represented by 0. And minus 5 is represented by 1. So it has to be represented between what? 0 to 7. So these quantized value will be represented using 3 bits. So there are 8 levels. You need to use only these 3, that is these values from between 0 to 7 to represent this quantized value. Okay, so now we need to send this data. Okay, we need to send this data to the other end, okay, wirelessly. So minus 1 is represented by what? 3. Now 3 will be represented using 3 bits. So 0, 1, 1. So 3 can be represented using what? 3 bits. 0, 1, 1. Next 6 can be represented as 1, 1, 0. Next 7 will be represented as what? 1, 1, 1. Next 6 is represented as 1, 1, 0. Next 4 is represented as 1, 0, 0. Next 1 is represented as 0, 0, 1. So similarly all the other values would be represented in a binary format. So this decimal number is converted to what? Binary format. Then this data will be transmitted over the channel, okay, to the other end. So when you transmit this, so this is how the data would look like. So look over here, 0, 1, 1. So it is 0, 1, 1. Next followed by 0 followed by 4 ones. Okay, so if you look over here, so this is 0 followed by 4 ones, next 0. So this is your 0 followed by 4 ones, then you will be having 0. Then again they will be having 5 ones followed by 0. So you need to convert this into one single row vector. Okay, this code will be converted to row vector and it will be transmitted, and the continuous row vector is represented over here. Okay, then what we need to do, we need to take this code and again you will be converting this back to decimal, then again you will be dequantizing that to get these values. Okay, and then what that dequantized value will be representing the signal which will be reconstructing. Okay, so whatever the signal which will be getting will be almost similar to the signal which you transmitted. Okay, this signal should match with the original signal which you are quantized. Okay, so there will be some amount of error, so that error will be called as quantization error. But you may look, it has lost some shape, but it is almost resembling your original signal. Okay, this is what PCM is all about. Okay, so first you'll be taking the signal, you'll be representing the number of bits which is used to represent the PCM, how many bits will be used, and the number of levels depends upon 2 to the power of n. So there will be 8 levels which is used to represent the quantization levels. And then the first thing is take an signal, sample that signal, will be getting discrete value. That discrete value will be quantized, then that would be converted to binary. That binary stream will be transmitted at the receiver end. So the whatever the binary data you have transmitted will be received, converted to integer, then it will be dequantized, and then it is represented as a signal. So this is the process. Okay, so now whatever I have explained will be written in terms of a program. So this is your MATLAB program. So CLC means clear screen, close all, clear all. Next, so the first thing is we'll be asking for what n is equal to input, enter the value for n bit PCM. So here n is a variable, so that will be storing how many bit PCM you will require. So you may enter any value. Let us consider n equals 3. Then n1 is equal to input, enter the number of samples in a period. So whenever you consider a sine wave, okay, if you need to sample that, so you need to represent number of samples. Okay, so you may represent any number of samples, better if it is greater than 2 to the power of n. Okay, that will give you a better result. Okay, so the number of samples you have taken it as 8. Okay, you used 8 samples to represent this sinusoidal wave. Okay, next you are considering a sinusoidal wave x. Okay, s is equal to 8 sine of x. Okay, 8 sine of x. So the amplitude of that would be what? 8. So the maximum amplitude is what? 8. That is what was shown in the output. Okay, the maximum amplitude is what? 8, and the minimum amplitude is what? The minus 8. Okay, so x x is nothing but this coordinate x. So x is equal to what? 0. It starts from 0 to 2 pi by n1. Okay, this is the number of samples. Okay, depends upon the number of sample up to 2 pi. Okay, 0 to 2 pi. Okay, so the number of samples here, what you need to consider, that is taken as what? n1. So I have given n1 over here. Okay, then you will be considering a sinusoidal wave. S is equal to a sine of x. Next, a display sample value, that is display values given by s. So that is what was shown here until here. If we consider until here, so what you have done right now, you have constructed the analog signal. Okay, the next part, so subplot of 3 comma 1 comma 1. So out of 3, okay, you have taken 3, you have taken 3 plots, 1 2 3. Out of 3 plot, you are using what? A first plot to plot what? S. S is your signal. You are naming that as what? Analog signal. Okay, so this is what? Amplitude. Y label is amplitude and your x label is a time. So in order to represent this signal, you are making use of these many instructions. Okay, the next thing is you need to sample the signal. So this is the second one. You need to sample the signal. You already know that in order to sample the signal, you just need to make use of a stem function. When you make use of stem function, you will be getting the sample signal. Whatever the original signal is there, its sampled version is shown over here. The next thing is you need to quantize this signal. Okay, in order to quantize the signal, this is the formula we will be using. Okay, so delta, we need to consider the value delta, which is given by V max minus V minimum divided by L. Okay, so the delta will be given by V max minus V minimum divided by L. L is the number of quantization level, so that is given by so L is equal to 2 to the power of n. So we have taken that earlier and we take over here. So this is the value. L equals what? So this L equals 2 to the power of n. So delta equals V max minus V minimum by L. So L equals 2 to the power of n. Okay, so in order to perform quantization, there is an already predefined function called as quantize. Okay, we will be calling that function. Into that function, we need to pass the values of s. So the values of s is nothing but the analog signal which you constructed. Okay, along with that, we need to pass other two values, that is part and code. Okay, so part will be varying from V minimum to V max. Okay, it will be varying from V minimum to V max, and the interval, okay, if this is the minimum and maximum, the interval between these, okay, will be given by delta, and delta is nothing but what? V max minus V minimum divided by L. Your Vmax value for the signal which you have taken is how much? 8 is the maximum amplitude. Minimum amplitude is minus Vmax, that is minus 8. Okay. Next, the code. Okay, the code is given as V minimum minus delta by 2, and the interval is again delta, and the last value will be Vmax plus delta by 2. When you pass these things into the function as parameter, you'll be getting the output which is Q. Okay, Q is the quantized level. Okay, Q is the quantized level, and IND is the indication, or whatever the quantized level is there, that will be represented by some integer values. That integer values indicate your IND. Okay, so now we have got what? Quantized values. Okay, that is quantization levels is given here. Okay, so taken a signal, you sampled, you have taken a signal, you sampled the signal, and you got the quantized value, that is Q. Okay, quantized value, that is Q. So that is plotted over here. Before plotting, what you need to do is, so usually index in MATLAB starts from 1, so you need to round it off so that it starts from 0. So you are doing that by making use of this for loop. Okay, you are doing this to make the index from 0 to n instead of from 1 to n. Okay, display the quantized value. So as I said earlier, Q is the quantized value. I will be making use of stem function. We'll be making use of stem function, and you will be plotting that signal, that is your quantized signal. Okay, next, so we'll be naming that as quantized signal. This is your amplitude, and this is your time. So now you have finished all these three representation. Okay, and now encoding process. So next is what? Encoding process. So in encoding process, what you need to do is, whatever the quantized value which you have got, it has to be represented in terms of what? Some code. Okay, you just look over here. Whatever the quantization is represented here, be represented in terms of what? Binary values. So in order to do that, we'll be making use of decimal to binary. Okay, decimal to binary of the code. Okay, decimal to binary of the code. So if you look over here, so this is your sampled values. Okay, next, these are the quantized values. Then these quantized levels are represented by this indicator values. Then these indicators or code is represented in terms of binary. Okay, so the same thing is done over here. So you have quantized values, and you have a code. Okay, this code has to be converted to what? Binary. So decimal to binary of this code, you'll be getting that is being displayed. Okay, once it is converted to binary, so next process is what? We need to convert. Okay, so once you convert this decimal to binary, we need to make it as a single vector, 0 1 1, next 1 0 0. So it has to be in one row. Okay, so that can be done by making use of matrix to code row vector. So this function performs the matrix to code vector. Okay, code row vector. After doing that, it will be plotting that. Okay, it will be plotting that. So the plotting is shown over here. Okay, so this is the plotting of that row vector. Okay, so until here we have finished. Next thing is what? We need to demodulate and represent the signal. Okay, this is your demodulation process. So you just need to reshape whatever the code which was sent to you. And now in order to do that, so the binary value which you have got, okay, so the binary value which you have got is has to be converted into a decimal. So a binary value is converted to what? A decimal value. So what is that? Quantization value will be considered to decimal. Okay, this is converted to decimal. Then you will be representing that plot of Q. So Q is, this is the signal. Okay, so you will be performing demodulation. Before that demodulation, we need to convert this binary to decimal. When you get the decimal value, you will be using a dequantization process. So the Q is equal to del cross index plus V minimum plus del by 2 plus 1. So this is your demodulation process. Okay, so this is regarding the program. So I will be uploading the code along with this video. Just download the code and try to execute in your home if you have got laptop and MATLAB installed. If you don't have a MATLAB software or laptop, you can execute in the college.